Okay, let's try question number 32. Sine is given to be negative. So let's attack trigonometry by doing a nice karate chop. Hiya. ASTC. So sine is negative. We know that sine is positive here and here. All things are positive, sine is positive. So therefore, sine must be negative here or here. So let me erase this because we're not talking about when sine is positive. We're talking about the opposite when sine is negative. So it's got to be here. Now we also know that given cosine is positive. Cosine is positive here and here. So the quadrant that theta must be in, that is fulfilled by both criteria, is in this quadrant here, which is 1, 2, 3, 4. We're talking about quadrant 4. IV means 4. Okay, so here I am on Desmos.com, and you can click on the toolbar, play with the settings. You can even play with the domain and range. I'm just gonna change the range setting here from -2 to +2. You can see a bit more height on the graph. I'm in degree mode, and I made the angles go by 90 degrees. So this is 0, 90, 180, etc. And what I want to do here is to just divide these angles up to 4 sections, 4 quadrants. X equals 90, X equals 180, X equals 270, and X equals 360. So these are vertical lines, and I want you to really concentrate on sine, the sine function. And when we say Haya, ACC, check, check, sine is positive in the first and second quadrant. So doesn't that make sense? We always say that sine is positive in AS. All things are positive. Sine is positive, and it's negative in quadrants 3 and 4. So this graph makes sense with that nice acronym that we memorized. Now what about cosine? So cosine starts high, then goes low, but remember the acronym ASTC. According to this, cosine should be positive in quadrants 1 and 4. And you can see that the y value indeed is above the x-axis in quadrants 1. This is quadrant 1, and this is quadrant 4. So this mnemonic makes sense according to the graphs. Let's try tan. So y is equals to tan of theta, or tan of x. So this is a very interesting shape. It looks like we're starting at 0 here. We're shooting off to the moon, and we're reappearing off the other side of the universe. And then we land here. So this is one entire period. It's only 180 degrees. We memorize this graph more thoroughly in the pre-calculus 12. But right now, it keeps on repeating over and over again. So Haya, ASTC, tan must be positive in this quadrant and in quadrant 1. So 1 and 3. This is quadrant 1. You can see that tan indeed is positive. It's above the x-axis. In quadrant 2 it's negative, and in quadrant 3 indeed it is positive. So this makes sense visually if you memorize the graph. Okay, so now we're going to solve another classic trig equation, and the standard domain is between 0 and 360 degrees. So in pre-calculus 11 we really focus on solving the basic equations, and in pre-calculus 12 we'll go beyond 360 degrees. So what we're doing now is a very routine, regular math question. We have an unknown angle. Trig, sine, cos, or tan of some unknown angle is equal to some special number, and we can do it even without a calculator. So let's try. How do you attack regular trig equations? Haya. ASTC, all students take calculus. And sine is positive. Pay attention to the sign, because when sine is positive, we know that it must be in this or this quadrant here. A and S. S stands for sine is positive. Sine of what is 1/2? This is where you need to practice memorizing your special triangles. So this triangle here is 1, 2, √3. This is 30. This is 60. And we know that sine 30 is 1/2 because sine 30 is opposite over hypotenuse. So try to be as quick as possible to figure out these nice reference angles. So when we say 30 is the reference angle, it is correct here as well because it's in this quadrant here. We also write the reference angle 30 here. So there we have it. We figure out what the angle is. Starting here on the right in standard position, we go counterclockwise, and as soon as we hit the terminal arm, that's our answer. We say theta 1 is equals to 30 degrees. So the rule is we need to go between 0 and 360. We keep running the track. Run, 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 and the next answer is at 150. Theta 2 equals 150. Alright, so we have our first two answers. If you really wanted to run the track again, you could get more answers, but we're constrained for only one full lap. 360 degrees is one full lap, and we're going to stop. So usually there's two answers. So there are a lot of steps to solve these trig equations, but hopefully you get the hang of it, and eventually you realize that these are not very hard. Sine of some unknown angle is equal to some special number. How do you attack it? Hiya. ASTC. Very repetitive, and eventually you'll be very fast at these. Sine is negative. Where? Sine is negative here and here. 1 over √2. Hopefully you can memorize that the reference angle would be 45. Sine 45 is 1 over √2, so it's going to be reference angle 45 degrees here and here, 45 degrees. All you have to do now is run the track. On your marks, get set, go. 180 plus 45 is going to be your first answer. 180 plus 45 is 225. That's your personal best, and you ran out of steam. But the second time you do a run, you have more endurance. You can run all the way around here, which is 315. So these are the first two solutions, and that is within the domain. Okay, so let's try this one here. Same old, same old. We have Haya, ASTC. Sine is positive. There's a hidden positive here, over here or here. Sine of what is √2 over 2? We're talking about 45 degrees. 1 over √2 is the same thing as √2 over 2. 45 is a reference angle. So all we do is run the track. Your first angle, A1, is 45 degrees. And the second time you run, you have more endurance. You can run all the way this far, which is 135. A2 is equals to 135 degrees. Alright, so let's keep going here. We're going to keep on practicing. Sine of beta is equals to negative √3 over 2. So these questions are almost all the same. Haya, ASTC. Now we're dealing with a negative value, whereas sine negative, it's negative here or here. Sine of what angle is √3 over 2? Just focus on this value here. It's going to be sine 60. So the reference angle is 60 degrees, which is about here and here. So all we have to do to figure out beta is to run the track. So beta 1 is equals to, I better make my beta a bit better. So this here is my little beta 1 is equals to 180 plus 60, which is 240. And my beta 2 is equals to 360 minus 60, which is 300. Alright, let's try another one. Let's try this question over here. Cosine theta equals negative 0.5. That's negative a half, same thing. So these are getting very repetitive now. Haya, ASTC, cosine is negative here and here. cosine of what is 1/2? It's cosine of 60. So I challenge you to build up your speed. If you go to thatquiz.org, click on trigonometry, you can practice these types of questions to get really fast at them. So what we have here is 180 minus 60 is 120. So theta 1 equals 120. And this is 180 plus 60, which is 240. Okay, so let's copy this question on the right here. Tan x is equals to positive root 3. Again, we don't need a calculator. We have an unknown angle. How do you attack these kind of trig equations? Hiya, ASTC, tan is positive here and here. Tan is always a stick, it's a straight line. Tan of what is root 3? It's going to be tan 60. Tan 60 degrees is root 3, so the reference angle is 60. And to figure out the angles, we just run the track. x1 is equals to 60 degrees. And then x2 is going to be 180 plus 60, which is 240. Alright, finally we need a calculator. Let's try this one here. Tan theta is equals to -2. So unfortunately this is not a special triangle. We need to actually use a calculator. But we can apply the same principles. How do you attack a trig equation with an unknown angle? Hiya, ASTC, tan is negative here or here. And really focus on the value only, not including the sign. In degree mode, because we're working with degrees, hit tan inverse of 2, not tan inverse of -2. I recommend tan inverse of just the number part, not including the sign. So tan inverse of 2 in the reference angle is approximately 63.4 degrees. So we draw a nice stick here. 63.4 is the reference angle, 63.4. And now we can figure it out. Theta 1, you run the track this way, is equals to 180 minus this reference angle, which is approximately 116.6 degrees. And if you run the track a bit further, you go all the way here, which is 360 minus the reference angle, which is 296.6 degrees. Okay, so notice how we're dealing with the angle in this question here. X has nothing to do with the x value. We're talking about an angle x. Similarly, in this last question, please do not be confused and think that pi has anything to do with an angle. This is just a number. You might as well replace this with 3.141. 3.14 is just an estimation of pi. It's just a number. Do not think of this as 180 degrees. So let's attack this trig equation. It has an unknown angle, so we attack it by going hiya. ASTC, sine is positive here or here, and we do need a calculator. Just hit sine inverse of pi, or sine inverse of 3.14. Now hold on, we don't have to waste our time figuring this out because we understand there's no solution. So just as in a little aside here, you know how to sketch sine. Sine goes pow. Sine goes up and it goes down, it goes down and it goes up between 0 and 360 degrees. But the range is between +1 and -1. So when you're asking y is equals to sine theta, yes, we know the graph goes up and down. It has a range of between -1 and +1. But when you're talking about another y value that's flying way up here, this is y is equals to pi, or 3.14. You know there's no solutions. It's not going to work. No solutions is the answer. But if you're curious, what happens when you hit sine inverse of pi? Okay, so as expected, we get an error, so that's impossible. No solution. Okay, so now it's your turn. Good luck.